Okay, so the first kind of nomenclature naming system we're going to do is binary nomenclature. Okay? Binary nomenclature. Now, this is not going to be real easy because you don't have a periodic table. I don't think there's one in your book. Can you look at the index in the back of the book and see if there is a periodic table? I don't think there is. The index. Okay, so we'll have to do with this as we can. Okay, so the first class of nomenclature is really the simplest. Okay, now we use the European version, and that is numbering the columns 1 through 18. Yes? Now, you'll notice that 1, 2, and 3 are basically all metals, correct? 1, 2, and 3 are all metals. But 1, 2, and, let's see, I have 18, 17, 16, 15, 14, 13. So 13. So this is going to be, for instance, this is boron and aluminum, right? Boron is up top of this column, and then aluminum is next. In number 1, you have hydrogen, and underneath that you have lithium, and then underneath that you have sodium, and underneath this you have beryllium, magnesium, potassium, calcium. Yes? So let's just work with those metals for now. Okay? You'll get a periodic table. I will manufacture one. Is there anything listed in your book? I don't think there is, right? What is it? I can't hear you.
There's a small one.
Oh, all right. All right, yeah. You can use that. What page is that on?
117.
Yeah, 117. Turn to page 117. And what you can do is you can at least see the columns. You know, it's just symbols, right?
Yeah,
they're just symbols, which is fine. That's all you need, really. Yeah, that's fine. That's good. That's more than enough. All you need is the symbol and the column. So let's continue this. What's under potassium? Under potassium. Look at K, first column. Yeah, rubidium. Okay? What's under rubidium? CS. Anybody know what that is? Cesium. What's under calcium? No, it's not francium. Francium's down here, and I think that's what you meant. Right? What is under calcium? SR. Strontium we've spoken about. Strontium, there's a radioactive isotope of strontium that can replace calcium in bone tissue, which can give you cancer. What's next to cesium? They used to use it in enemas to see the lower GI tract. Barium, radioactive barium. And then next to francium, Ra, radium, which they used in watches, watch dials, watch numbers, glows in the dark. Okay? And underneath aluminum, we don't really use it in binary nomenclature too much. What is it? GA. What's GA? What's GA? Gallium, yeah. Okay, good. Now, so these are the metals. Okay? Now the metals in binary nomenclature, okay, are written on the left. You have two sides. You have a left and a right. Now, in binary nomenclature, you only have one type of element on the left, which is a metal. Okay? This is a metal. This is a non-metal. Correct? This is going to be plus, and that's going to be minus. Okay, so the metal's going to be plus, and the non-metal's going to be minus, right? So, something from groups 1, 2, or 13 is going to bond with something from 16, 17, or 18. Okay, sorry, not 18, but actually you can say 15 too. This one, and we'll do an example, this is plus minus 4. Okay, and I'll show you what that means in a minute. We'll put down carbon as the big one. Okay, carbon. But this is going to be nitrogen, this is oxygen, this is fluorine, chlorine, bromine, iodine, right? Now, how far is this column away from the noble gas? 1, right? So if it gains 1 electron, it's just like a noble gas. We don't care about the octet rule. I don't care. I don't teach the octet rule. I hate it. I think it's rabbit hunting. I call it rabbit hunting. I think it's stupid. You just look at where the noble gas is. Yes? You look at where the noble gas is. So it wants to be like a noble gas. So this just has to gain 1 electron to be like the nearest noble gas. This has to gain 1. These all have to gain 1. So when it gains 1, when it bonds, it's going to have a charge of -1. Yes? When this column, when this column, this has to gain 2 electrons. So after it bonds, it's going to have how many excess negative charges? 2. So it's going to have a charge of what? Yeah, the whole column is going to be -2. There's no question. There's no exceptions. We don't worry about exceptions. It's nonsensical. Clear? And what about 15? -3. Now, we will get into exceptions with nitrogen, for instance. And we're not going to worry about that right now. We're just doing a very straightforward binary nomenclature. Clear? Okay. Now, so let's take sodium. What's under oxygen? What's under sulfur? Anybody want to help me out here? Or? What is it? What's under sulfur? Yeah. What's the symbol? Se. Yeah. Selenium. Okay. What's under nitrogen? Phosphorus. What's under phosphorus? Yes, arsenic. Every time I think of arsenic, I think of an old play that they made into a teleplay called Arsenic and Old Lace. It's actually pretty funny. Okay, now, so let's say I bond magnesium and chlorine. What's the formula? What's the formula? Now, the rule that I may not have said to you, the net charge of any compound has to be 0. It has to be 0. Okay? So, how many of each am I going to need to get it to 0? Anybody? It's simple stuff, man. This is basic 4th grade math. Well, not really, but yeah. -1. I don't understand. You're throwing numbers at me. House. I mean, what do you mean? -1? No, I need to know how many of each. -1 doesn't help me. Like how many magnesiums and how many chlorines? What's the shortest? What's the smallest combination? The smallest ratio of magnesium to chlorine? Yeah. Yeah, exactly. 1 magnesium and 2 chlorines. The way you indicate the number of atoms in a formula is using a subscript. So this reads, the way I would read this, MgCl2. That's how I would read it. If somebody said to you, what chemical is that? I'd say MgCl2. That's how you read it. Or you could say, how do you name it? Anybody know how to name it? Magnesium chlorine? Magnesium chloride, yeah. You have to modify the ending of the non-metal with the suffix. You know what a suffix is? What's a suffix? What does the word suffix mean? Adib? The ending. Yeah, is that what you meant by that? That was kind of cool. Very smooth. Okay, excellent. Go like this. Excellent. That's all you had to do. I got it. Okay, good. So it's magnesium chloride. Okay, yeah. What about potassium and aluminum? No, sorry. What about aluminum and, here's a hard word, aluminum and oxygen. Aluminum, what's the charge of aluminum? What's the charge, what is it? +3, yeah. We didn't do that over here. Right, we didn't do that over here. How many, what's the charge of group 1? What's the charge of group 1? +1, right? Because if it gives up 1, it's just like a noble gas, right? Yes? Yes? Okay, yes, okay. So this is all, and this is going to be +2, right? Yes? All right, so this is going to be +3, and then oxygen is going to be what? What is it? What's oxygen going to be? What is it? What's oxygen? Guys, come on.
-2.
-2, yeah, it's right in front of you. Right? Yes? Okay, so what's the formula? What is it? Yeah, very good. Al2O3, right? So the best combination, you know what lowest common multiple is, right? Least common multiple, right? So it's going to be what? 6, right? What does both go into evenly? So it's going to be Al2O3, right? Yes? Okay, now, so let's do this. Let's do this. Let's do a quick exercise. Right? You see why it's a good idea to know parts of the periodic table? Simple parts just makes life a lot easier. All right, let's put a few things down here. You're going to have to put the charges in. And we'll put some up here. We'll put all right? So you're going to have to do the charges. Right? Now, what you're going to have to do is, and we'll do this orally, okay? We'll do this orally, but I'll put the formula down, but then you have to tell me the name. We'll go back to the name, okay? So, what is the formula for the first one? Anybody? All right, you want to do the charges? What's the charge of sodium? What's it? What? No, the formula is it, not the name. What is sodium? +1, +2, +3, -3, -2, -1. What's the formula of the first one? What is it? I can't hear you. I know you're being shy and you're speaking even lower. What is it? Na3N, yeah. Na3N. +1, -3, need 3 + 1. Easy, right? What's this one going to be? What's Na2O? What about the next one? Yeah, NaCl. What about the next one? Ca. Is that what you said? Is that right? What about the next one? Ca. Oh. Yes? What about the next one? Big on. What is it? CaCl2. What about the next one? Al. And what about the next one? Bauxite. The aluminum ore is called bauxite. And the last one? And what's the name of this? What about this? Sodium? Yeah, you gotta lose a syllable, I know. With nitrogen and phosphorus, you lose a syllable. Nitrogen, phosphorus, sulfur, you lose a syllable. So this is gonna be sodium nitride. What's this one? Sodium nitride? Calcium nitride. Sodium oxide. Easy? It's not so hard, is it? Simplest, yeah? So, what is significant about binary? There's no guessing. Everything is right through the periodic table. There's no multiple charges. You'll understand better what that means in about 10 minutes. But everything is very straightforward. Clear? You only have one element, one type of element in each, slot. Metal, non-metal, metal, non-metal, metal, non-metal, only, so it's just binary. This is aluminum and nitrogen, aluminum and oxygen, calcium and chlorine, there's nothing fancy, simple stuff. A lot of chemicals that you now know. You can just go to the periodic table and say, well, I know these chemicals now, and this is how you get the formula, and this is why. So now I'm giving you the key to hundreds of formulas on the periodic table that you can write the formula and the name of all those chemicals. Now, let me add to that about 3,000 chemicals to that, okay? I'm going to add to your knowledge. I'm going to probably multiply whatever knowledge you have now by 100. Okay? In 1 minute. Yes? All right, now. There's something called, now you don't have to understand the geometry of polyatomic ions. You have to just know that there are ions. Sodium ion, right? Is Na+1, right? Chlorine is Cl -1, right? It's just, they're ions, they're charged particles, yes? Now, you don't have to memorize these, but it will be good to know a few, to memorize a few, and I'm going to give you a few to memorize, just about 5 or 6, less than 10, right? Not many, okay? Ones that we'll be using a lot, and ones that you'll use all through chemistry and easy stuff, okay? And many of them you've heard before anyway. You've heard the words, okay? They're called polyatomic ions. And what polyatomic ions are poly means many or more than one. Atom, put together, that's an ion. And I'll give one that's very common, okay? Very common. It's how blood works, okay? Carbonate. You've heard of carbonate, yes? Sodium carbonate, calcium carbonate, right? Carbonic acid, the blood, the whole. How do you get this gas, this carbon dioxide, from the cells to the lungs? Well, it doesn't travel as a gas. That would be silly. You put gas through the blood. What it does is it dissolves as an acid. The carbon dioxide is produced in the cell. It dissolves as an acid, and then goes to the cell, goes to the lungs, and it's released as carbon dioxide. So you know this, and it's going to be carbonic acid, carbon dioxide and water. That's what happens. It's a little more complicated than that, but that's about it. Yeah? It's easy. Okay, so that's carbonate. Let's write that down. So you'll have to know, the spelling is important. You'll have to know that it's CO3, and you'll have to know that it's -2 charge. So that's one to memorize. Okay, give me another one. Anybody know what that is? What is it? Sulfate, yeah. You've heard of sulfate. Now, there are several positive ones, mostly negative, but the most common positive one, and you've heard of this, big in fertilizer, big in fertilizer, big explosive fertilizer, make a giant bomb out of it. Don't do that, okay? But it's no secret. In the United States, farmers have to register if they want to buy this particular fertilizer in bulk. You know, and if you're not a farmer and you buy a ton of this stuff, you know, the FBI is going to come knocking on your door saying, why did you do that? It's called, I'll give you two at the same time. That's the positive one you got to know. It's called, anybody know what that is? Ammonium. You've heard of that, right? So this is not something that's weird or anything. And it's 2 M's. Okay. Another one that I'll give you, yeah, that goes with this one. You know, if you want to make a bomb, okay? Oh, sorry, you don't want to make a bomb, but if some nefarious individual makes one, if you combine it with nitrate, yeah? Okay, yes? If you want your beef bacon, we don't have pork bacon here in this country, but if you want beef bacon, yeah, you want to put in it nitrates, yeah? Yes, another it could be a powerful explosive. It could be an oxygen generator. It's related to maybe sort of a little bit, maybe like whatever. I won't go there. Can be a powerful oxidizer. Anybody know what that is? Chlorine. Sounds like, what is it?
Oh, oxygen fluoride.
Chlorate. Yeah, that's a good one. I think is that enough? Yeah, I mean, a lot of these, like, I'll give you one more. I'll give you a really good one. Here's one that's in bleach. Bleach. Anybody know what bleach is? Okay, bleach. Bleach that you use to whiten your clothes uses the following polyatomic ion. Usually it's sodium, this. Okay, you ready? You know what it is? Bleach. I love to say the word bleach. I used to say to my mom every time she came home from the store, Mom, did you buy any bleach? She thought it was weird when I used to call it bleach. 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 I say blue and I say bleach. I know it's weird. That's why I always said it since I was a kid. Okay, it's called this. CLO. Anybody know what that is called? It's kind of a funny word. Yeah, it's weird. It's a weird kind of word. One word. Bleach. Bleach. Okay, it's called hypochlorite. If you look on the back of a bleach bottle, it'll say active ingredient sodium hypochlorite. Bleach. So you know many, you know, there are a few more I'll give you, but not many. I mean, I promise less than 10, right? 1, 2, 3, 4, 5, 6, 7. So I have 3 more. Okay.
That's enough.
Yeah, all right for now. But the reason I'm showing you these is because the main reason. Because many chemicals that you run up against are simply, they have polyatomic ions. And you say to yourself, well, how do I say CO3? People say, well, I don't know, carbon trioxide. It's just a polyatomic ion. You know, it's not. In other words, this forms ionic compounds like sodium carbonate, but carbonate, this is different, this is big, okay. You ready? This is an ion, and it forms an ionic compound with sodium carbonate, right? You okay with that? Okay. But carbonate is a covalent it's a covalent particle. Look at this one. This is an ion. It forms an ionic compound with nitrate, right? But this is a covalent particle. As a matter of fact, you know what it looks like? This is right here on the film. Okay. What it looks like is this. All right, let's draw it a little bit better. It's a tetrahedron. Tetrahedron. In other words, it looks like this. It's a perfect, you ever hear of diamonds? Diamonds is tetrahedral, right? Diamonds tetrahedral. You know, it looks like this. Well, every bond is 109.5, 109.5, 109.5, 109.5, everything. Every bond angle on that is 109.5. Diamonds. Carbon. Forms a network, carbon, and it's all 109.5. Diamonds is a tetrahedron. Okay? So this is and the way you draw it is you draw it like this, right, like that, right? And you draw, say, +1. So, yes, that's an ion, and it forms an ionic compound, but the particles, the polyatomic particles, are very stable, and they are covalent. They're covalent particles. They're not covalent compounds, because they're ions, but they're covalent particles. Okay. Chemical ice pack. Anybody use one ever? No? Nobody? You've heard of it. Yeah, you've used one. Yeah, and you've used one. Okay, so it's a bag, plastic bag, right? And it has salt. It has what sounds like salt. It is salt, like sand, right? And then inside that you have another bag full of water, and you punch it. You break the right? You break the bag of water inside, and you mix it, and it drops down to near 0 degrees Celsius. And that's an ice pack, chemical ice pack. That's ammonium nitrate. Yes? Absorbs enormous quantities of heat. It's endothermic. Absorbs heat from the surroundings. Well, what's the surroundings? Well, your hand, your ankle, whatever you injured. Okay? So now, what can I do? These are stable charges. These are all charges that are always. If I say to you sulfur, you can bet $1 billion that the charge will be -2. Yeah? Yeah? Yes? So what? So what? Well, that's big. That's big. Pick a metal. Give me a metal. Any metal. Pick a metal. Pick a metal. You know, one from 1, 2, or 13. Pick one. What is it? Lithium. Okay, good. Pick a polyatomic ion. Anything. I just had 7 on the board. What? Carbonate. What's the formula? What's the formula? I didn't ask you what the name is. What is it? No, this was plus 2, remember? Now, what's the name? Yeah. In other words, you don't modify the polyatomic ion with anything. No prefix, no suffix, just the name of the polyatomic ion. So the name of this is lithium carbonate. Yes? Easy? Yes? Yes? Easy? Okay. So I have, how about this? I'm going to give you another one. This is big. This is huge. Phosphate. Big. That's your 8th one. Phosphate. So I take this. You ready? What's that called? Yeah, bone. Now you know what? Now you know the chemical formula for bone. Calcium phosphate. So these make chemicals that, gosh, you are enormously familiar with this stuff. What is it? I mean, you already are. You've heard of them. You've heard the names somehow in the background. Now here's one, and then we'll end with this, and then I'll give you a little bit of homework, okay? Now, you ready? And this homework is big because you're gonna have a quiz tomorrow. Okay, so it's big homework. And you gotta use some creativity, you gotta be independent, and you gotta actually do it, or you're never gonna pass the quiz. And it's an easy quiz if you just do the homework. Easy quiz. Now, if you put H, if you take a negative polyatomic ion, yeah, and H, positive H is +1, right? You get a type of acid. Pick a polyatomic ion. What is it?
Chlorine.
Chlorine. Oh, I like that. That's powerful. Here, I'll give you one that you already did. Right? What was the, yeah. Okay, so this is, what's the formula for this? What's the formula? What's the formula? +1, -1. Come on, guys, you can do this. HClO3. What's the name of it? You have no idea, right? Well, the old, this is the, you know how you do the name? You do the name? You do it like this. You ready? 8 becomes ick. So chlorate becomes chloric. Is that easy or what, dude? I mean, now you know 5th language. Chemistry. Chloric. Carbonate. You gotta get a syllable. What's this? What does this become? I already told you the name of it, and you already know the name of it. But carbonic. Yeah, add that extra syllable. Carbonic, right? Now, and this is it. We're almost done, okay? So that's how you do, you know what these are called? These are called, they have 2 different names. 2 different names. They're called oxy acids. They're also called ternary acids. Right? Yes?
If you add hydrogen with any of the polyatomic ions, then it turns into IC.
If it's 8, it becomes ick, and I'll show you. Yeah, just 8 becomes ick. Don't worry about it. That's it. Okay. Now, the last thing is, and then I want to show her something, so I got 1.5 things to do. But what happens if you have a negative element? You know, like a halogen or sulfur, right? And I'm going to add acid. What about those kind of acids? This is HCl. This is HF. This is H2S. How do you name those acids? These are called binary acids. They're called binary acids. Binary. How do you name a binary acid? Always, always, always. You ready? Prefix. You're not going anywhere until I'm finished. You go prefix, hydro. Suffix, ic. Hydrochloric. There you go. You already knew that, didn't you? Hydrochloric, hydrofluoric, hydrosulfuric, hydrophosphoric, hydronitric, hydrobromic, hydroiodic. Got it? You got it? Now, she says, well, wait a second. For the oxyacids, 8 becomes ic. So what if you don't have 8? What if you don't have 8, right? Well, all right, fair enough. This is oxyacids. All right, you ready? Because sometimes you can have this. You can have sulfite. So you can have sulfite. So you have sulfate, sulfite. Sulfate is SO4, sulfite is SO3. Same charge, right? You can also have phosphites. Right? Yeah? You ready? Ite becomes us. Ite becomes us. Yeah? Remember I said hypochlorite is bleach. Hypochlorite is bleach. HClO. Hypochlorous acid. Yeah? Okay? So this is sulfurous, phosphorus, okay? As opposed to sulfuric, as opposed to phosphate. Okay, got it? We'll review tomorrow. And your homework is this. This is your homework. I want you to make up one, just 3x3, a 3x3 chart. Okay? 4x4, I guess, but it's really 3x3. In other words, here, I want you to put a positive ion here and a negative ion here, and then make the formula and names. Okay? See? See that? So you do one for binary, one for ternary, and one for acids. Easy? The acid is easy. The plus is all H's. It's just H. You know, so you just have just one thing, just H. Yeah? So you know, it's actually just 1x3, the acid one. Where the ternary and the binary are 3x3s. Yes? And you turn that in tomorrow. That's homework. And then you're going to have your quiz on that. Yeah? So in other words, you want to do a practice quiz? Okay? Yeah. Here's one. I'll give you 2 problems. You ready? I'll give you 2 problems. Okay? So if I give you a formula, you have to name it. So what's the name of that? No, the name, dude. Sodium chloride. So you got that one right. What's this? What's the formula? BaSO4. Okay, that's it. Have a great day.